Let's wrap up section 1.5. In this section, we learned about the theoretical methods of conducting a hypothesis test for data with one categorical variable. From the central limit theorem, we know that as long as our data contains at least 10 successes and 10 failures, the normal distribution will be a good approximation of the shape of the simulated null distribution. In other words, we know the null distribution will be roughly bell-shaped and symmetric. We can calculate the approximate standard deviation of the null distribution, or the standard deviation of the sample proportions, with the formula square root pi naught times 1 minus pi naught divided by n. Note this is written in function notation. You would read the left-hand side of the equation shown as standard deviation of p hat, not the standard deviation times p hat. The standardized or test statistic for one proportion, then, is z equals p hat minus pi naught divided by the standard deviation of p hat. Be sure you know how to calculate as well as interpret these two values. Example interpretations are on slide 4 of the section 1.5 intro and slide 10 of the sections 1.2 and 1.3 wrap-up, respectively. Let's compare and contrast the two approaches. Regardless of the method of analysis, the first, second, and last steps shown here are the same. Come up with a research question and write your hypotheses. The null will represent random chance, the alternative what you hope to prove. Hypotheses are always written in terms of populations. Then, collect your data so you can answer your research question. The actual analysis does differ slightly. Recall in the simulation approach, we simulated the chance model, then compared our data to the simulation. This allowed us to see how likely or unlikely it would be to get our observed result if in fact the null hypothesis were correct, and allowed us to calculate our p-value. In the theory-based methods, we did not simulate anything. Instead, we calculate the standardized statistic and compared that to the standard normal distribution to get our p-value. The p-value is the area in the tail in the direction of the alternative hypothesis in both analysis methods. It is the proportion of simulations at or beyond the observed statistic in simulation, or the area under the curve beyond the standardized statistic in the theory. The p-value can be interpreted the same way, regardless of how it was obtained. Finally, ignoring method, we make a conclusion about the alternative hypothesis based on the calculated p-value. So when should we use each method? There are many advantages and only one disadvantage of theory-based tests. Advantages include we don't have to do any simulation, it's fast and easy, can be done on a TI calculator, as well as lots of other software. We will all get the same p-value, and it is easier to determine confidence intervals, which we'll do in Chapter 3. It's also the more commonly used method in current research. However, theory-based tests will not always work. We have to have the validity condition, like success and failures for one proportion, in order for the central limit theorem to kick in and the theoretical method to work. If we use the theory-based approach, even though the validity condition is not satisfied. Let's use this as an example and test it out. Suppose we're doing 12 repetitions of the rock, paper, scissors test, and one of the 12 repetitions had scissors thrown. Let's open up the one proportion applet to find the p-value using both the simulation and the normal approximation. In the applet, plug in a null value of 0.333, a sample size of 12, and run 1,000 samples. Find the p-value for the observed statistic of 1, or 1 out of 12, which is 0.0833, and also check the box for normal approximation. You should have gotten a theoretical p-value of 0.0331 and a simulation p-value close to 0.059. Those are very different numbers. The simulation p-value is almost double the theoretical p-value. In fact, the theoretical p-value says that the evidence is strong against the null hypothesis, while the simulation approach only gives moderate evidence against the null. Which p-value should you believe? The one from simulation, because there is only one success, not 10, so the validity condition is not met, the central limit theorem does not apply, and the normal distribution should not be used to approximate the simulated null. This concludes Chapter 1. At this point, you should be able to write hypotheses in words and notation for a single proportion, define the parameter of interest for one categorical variable, simulate a null distribution and use it to calculate a p-value in the applet, calculate a standardized statistic using either the standard deviation of the simulated null distribution or the formula for standard deviation of a sample proportion. Use a p-value or standardized statistic to assess strength of evidence, and write a conclusion to a research question based on a p-value, a standardized statistic, or through comparing observed data to a null distribution. At this point, you should also be able to interpret each of the following numbers in the context of the problem: the sample proportion, or the statistic for one categorical variable, the population proportion, or the parameter for one categorical variable, the p-value, the standardized statistic, and the standard deviation of the sample proportions.